In this video, I'm going to show you to Edexcel A-Level Maths, Paper 1 from June 2019, Question 10. My name is Sunil Tanner. I'm a tutor and author. I live in Buckinghamshire, England. I'm available for online tuition and in-person tuition if you live locally. Question 10, Part 1. Prove that for all n, where n is a natural number, n squared plus 2 is not divisible by 4. So a natural number means a positive integer. Okay, so there's two possibilities. For n, it could be an even number or an odd number. So we could say n, let's put part 1 here, is always even or odd. If n is even, let n is equal to 2k, and this would tell us that n squared plus 2 would be 2k all squared plus 2, which is 4k squared plus 2, which is not divisible. Make sure you use the word divisible, not divided by, because of course it can be divided by 4. Divisible by 4, because it won't give an integer answer. When you divide by 4, it's divisible means. It's not divisible by 4 as 2 more than a multiple of 4. If n is odd, n equals 2k plus 1, which tells us n squared plus 2 is 2k plus 1 squared plus 2. If we expand that out with FOIL, we're going to get 4k squared plus 4k plus 1 and plus that 2, which is the same as 4 times k squared plus k plus 3. And you can see that is also not divisible by 4, as this time it's 3 more than a multiple of 4, so it's never divisible by 4, so never divisible by 4. Okay, part 2 of the question. Given that x is a real number, the absolute value of 3x minus 28 is greater than or equal to the value of x minus 9. That's all in quotes. And giving a reason if the above statement is always true, sometimes true, or never true. Now, if it was always true, we'd need to prove it algebraically or graphically. If it was never true, again, we'd need to prove that algebraically or graphically. If it was sometimes true, we could maybe find an example where it works and an example where it doesn't work, so we could say sometimes true. Obviously, it's not obvious which one it is just by looking at it. So what I would do is start by thinking about the graphs. So we want to think about the graph of y equals modulus of 3x minus 28, absolute value of 3x minus 28. Well, if we initially start thinking the graph of, which I'll draw, let's do it in a different color, y equals 3x minus 28, this would be a graph like this, where the y-intercept was minus 28, and it was quite a steep gradient, and we could find this point where it crosses the x-axis by doing 3x minus 28 is equal to 0, and then you'd find that x is equal to 9 1/3. Now, in the absolute value, what will happen is the part that's underneath will reflect on the top. So this graph here of y equals 3x minus 28 would look something like this, where we found this value here was 9 1/3, and it would go up here, and the left-hand side here would be like that. And the equation for this part of the line without the absolute value signs is y equals 3x minus 28. And because we've effectively multiplied by minus 1 to get this side of the graph, the equation of this line of the graph is y equals minus 3x plus 28. Okay, now what we want to do is think about the line of y equals x minus 9. Now in that case, this will obviously be a graph that has a gradient of 1 and a y-intercept of minus 9. So it will go through minus 9 here, and if you work out the y value, the y value when the x value when y is 0, you'll see it goes through 9. So it goes through 9 here and minus 9 here, and the line will look like that. It looks like it crosses it in two places, and we can see here that that's y equals x minus 9, and we can see so that it looks like it's the absolute value of 3x minus 28 is larger in some places and smaller in some places. So it looks like it's sometimes true. I think you could so the answer is it's going to be sometimes. Just as a little bit extra, let's find the places where it crosses. So this point here and this point here. So what we can see here is the place where this crosses is when on the left-hand side here is when x minus 9 is equal to minus 3x plus 28. So rearranging that, we'll get 4x is 37, and then dividing by 4x is 9 1/4. And the point where the other point crosses here would be x minus 9 is equal to 3x minus 28. So add 28 to both sides will give us 19, and subtract x with 2x, so 9 1/2 is x. So the points where it crosses here are 9 1/4 and 9 1/2. So the answer is it's sometimes true. Now let's make sure we say it the right way round. We want this to be greater than or equal, so the diagonal, this V shape, to be above or touching the line. Sometimes true, and it's false in that middle region. Which is between 9 1/4 and 9 1/2. So it's false if x is between 9 1/4 and 9 1/2. And that completes question 10.